Some black holes are small. They weigh about as much as one star. Other black holes are so huge that they hold whole galaxies together. And then there are the strangest ones of all, black holes that might only exist in ideas, in math, not in real life yet. Today, we are going on a journey. We will climb through 5 different kinds of black holes. We will go from small, dead stars all the way to mind-bending ideas that scientists are still trying to understand. But first, what is a black hole? A black hole is a place in space where gravity has become so strong that nothing can escape it. Not even light. Imagine squeezing the whole sun down into a ball just a few kilometers wide. That squeezing would make gravity so powerful that it would bend space and time around it, like a trapdoor that only opens one way down. This edge is called the event horizon. It is the point of no return. Once anything crosses it, rocks, light, even information, it can never come back out. But here's something important: black holes are not vacuum cleaners flying around space, sucking up planets and stars for fun. They are simply what happens when physics is pushed to its limit. When a huge star runs out of fuel and falls in on itself, when matter gets packed too tightly, or when the strange rules of tiny quantum particles come into play, a black hole can form. And here's the real mystery: not all black holes are the same. Some come from dying stars only a little bigger than our sun. Others grow into monsters millions, even billions, of times bigger. And some black holes have only been predicted with math, nobody has actually seen them yet. That is where our journey begins. Let's climb, step by step, through the different kinds of black holes, from dead stars to strange quantum riddles. This is the full scale of the universe's most powerful and mysterious objects. Let's begin the journey into the dark. The story of black holes starts with stars, the giant balls of fire that light up the night sky. But stars don't live forever. When the biggest stars run out of fuel, they don't just fade away quietly. They explode. These explosions are so powerful that, for a moment, they can outshine an entire galaxy. What is left behind after this explosion can be something amazing: a stellar black hole. Not every star can become a black hole. Our sun, for example, is too small. When it dies, it will slowly turn into something called a white dwarf, a much calmer ending. To make a real black hole, you need a giant star, one that is at least 20 times bigger than our sun. When a star like that runs out of fuel, its center collapses. Gravity crushes everything, squeezing matter into an incredibly tiny, incredibly heavy ball. The result? An object that weighs between 3 and 100 times as much as our sun, but is squeezed into a space no bigger than a city. Picture that for a second: a black hole just a few kilometers wide, but as heavy as dozens of suns put together. If Earth's center were suddenly replaced with something like that, our whole planet and everything on it would be swallowed up in an instant. It's hard to even imagine numbers like this. It would be like squeezing the entire Himalaya mountains down to the size of a tiny pebble. So how do scientists find something that gives off no light at all? The trick is to look at what's around it. A black hole may be invisible, but it causes chaos nearby, and that chaos can be seen. If a black hole has a star next to it, it can pull gas away from that star. This gas doesn't fall straight in, it spins around first, forming a fast, spinning disk. This disk gets so hot, millions of degrees hot, that it glows with X-rays. Scientists use X-ray telescopes to spot this glow and find hidden black holes. Scientists can also find black holes by watching how stars move. If a star seems to be circling around something invisible, and that invisible thing is way too heavy to be a normal object, then it's probably a black hole. And now we have another amazing tool: gravitational wave detectors like LIGO and Virgo. These listen for tiny ripples in space and time, ripples made when 2 black holes crash into each other and merge. It's like hearing a cosmic drumbeat that tells us exactly where a black hole is hiding. One of the most famous stellar black holes is called Cygnus X1. It was discovered in the 1960s and is about 6,000 light-years away. At its center is a black hole about 21 times heavier than our Sun, orbiting closely with a giant blue star. This system gives off so much X-ray light that scientists couldn't ignore it. After years of study, they proved it really was a black hole. This discovery was such a big deal that the famous scientist Stephen Hawking made a fun bet. He bet that Cygnus X1 would turn out not to be a black hole. When all the proof came in, he admitted he was wrong. Gravity had won again, just like always. Scientists now believe there could be millions of stellar black holes hiding across our galaxy. Most of them are quiet, they aren't eating any nearby stars, so we can't see them. They drift silently through the Milky Way like ghosts, invisible unless they leave us some kind of clue. Stellar black holes are more than just leftover pieces of dead stars. They are nature's first big example of what happens when matter gets pushed past every known limit. They show us gravity's raw, unstoppable power. They are strange in every way, objects the size of a city, but with the weight of a whole star system, invisible traps we can only ever find by their shadow. This is where our journey through black holes truly begins. If stellar black holes are the small babies of the black hole family, and supermassive black holes are the giants that rule over galaxies, then what's in between? Logically, there should be middle-sized ones too, bigger than stellar black holes, but not nearly as huge as the supermassive kind. Scientists call these intermediate black holes, and they are one of the biggest puzzles in space science today. It sounds simple on paper. Stellar black holes weigh a few dozen suns. Supermassive black holes weigh millions or billions of suns. So somewhere in between, there should be black holes weighing hundreds or thousands of suns, right? And yet, even after years and years of searching, these middle-sized black holes are some of the hardest things in the universe to find. Why do scientists care so much about them? Because they might be the missing piece that explains how tiny stellar black holes eventually grow into the giant monsters found at the center of galaxies. Without intermediate black holes, it's hard to explain how the biggest structures in the universe were ever built. So what do we actually know? Scientists guess that intermediate black holes weigh somewhere between a few hundred and maybe 100,000 times the mass of our Sun. That's small compared to the true giants at the center of galaxies, but still enormous compared to stellar black holes. Imagine squeezing an entire cluster of stars down into something no bigger than the Moon. That's the size we're talking about. The problem is, finding them is like chasing shadows. Supermassive black holes light up the space around them as quasars, making them easy to spot. But intermediate black holes are quiet. They don't eat much, and they usually aren't sitting somewhere easy to see. So scientists have to search for small clues. One clue comes from dense star clusters, places packed with hundreds of thousands of stars. If a heavy, hidden object is sitting at the center, it will tug on the stars around it and change how they move. By watching those movements carefully, scientists can guess that a hidden black hole might be there. One example is a cluster called 47 Tucani, where the movement of stars hints that something with thousands of times the Sun's mass could be hiding at the center. Another clue comes from dwarf galaxies, small galaxies that sit near bigger ones. Some of these tiny galaxies seem to have black holes that are neither stellar-sized nor supermassive, but somewhere in between. One great example is a galaxy called HLX1, about 290 million light-years away. Scientists believe it holds a black hole about 20,000 times heavier than our Sun, almost the perfect example of an intermediate black hole. Sometimes, scientists catch quick flashes of X-ray light when an intermediate black hole eats a passing star. These flashes give some of the strongest proof that these hidden giants really do exist. But for every clue we find, new questions pop up. Why are intermediate black holes so hard to see? Are they just too quiet, sitting in places where they rarely eat? Or does nature somehow skip over them, jumping straight from stellar black holes to supermassive ones? This is what makes intermediate black holes so exciting. They could hold the secret to how galaxies grow, but they remain hidden, like missing pages from the story of the universe. As our telescopes and gravitational wave detectors get better, scientists hope to finally catch one of these black holes in the act of merging with another, giving us proof once and for all. For now, though, they stay a mystery, not common enough to be everywhere, not big enough to stand out. They remind us that the universe still has secrets, even about its most powerful objects. If stellar black holes are the seeds, then supermassive black holes are the giant, ancient trees of the black hole family. These are the true giants of the universe, black holes so massive that they weigh millions, or even billions, of suns. And unlike smaller black holes, these giants don't hide in random corners of space. They sit right at the center of galaxies, holding everything around them in place. Take our own galaxy, the Milky Way. At its very center, about 26,000 light-years from Earth, sits a monster called Sagittarius A star. This black hole weighs about 4 million times as much as our Sun, all crushed into a space smaller than the orbit of the planet Mercury. We can't see the black hole itself, but we can watch stars zooming around it at incredible speeds, some completing a full loop in just a few years. The only thing that could cause such fast movement is the invisible pull of a supermassive black hole. And Sagittarius A* is actually small compared to some others. A galaxy called M87 has a black hole more than 6 billion times heavier than our Sun. In 2019, scientists took the very first real photo of a black hole using something called the Event Horizon Telescope. That famous picture, a glowing ring of light around a dark shadow, was humanity's first ever look at the edge of a black hole, billions of light-years away. To put the size into perspective, if stellar black holes are about the size of a city, supermassive black holes are bigger than our entire solar system. So how do these giants form? Stellar black holes are easy to explain. A big star collapses, and gravity does the rest. But there's no single star big enough to collapse into something millions of times heavier than the Sun. So where do supermassive black holes come from? One idea is that they started small and grew over billions of years by eating stars, gas, and even merging with other black holes. Another idea is that in the very early universe, huge clouds of gas collapsed directly into black holes, skipping the being a star part completely. Nobody knows for sure yet, and solving this mystery might also help us understand how galaxies themselves were formed. These black holes aren't just sitting quietly, either. As matter falls into them, it releases enormous amounts of energy, creating what scientists call quasars, some of the brightest objects in the universe, bright enough to outshine an entire galaxy. These outbursts can even blow gas out of galaxies, controlling how many new stars can form. In a way, supermassive black holes are both destroyers and creators. They can stop new stars from being born, but they also help set the rhythm of how galaxies grow and change over time. It's amazing to think that nearly every large galaxy scientists have studied has one of these giants hiding at its heart. Without them, galaxies might not even exist the way we know them. Our Milky Way's spinning arms, our neighbor galaxy Andromeda, and countless distant galaxies are all shaped around these invisible anchors. Supermassive black holes are nature's grandest example of what gravity can do when given enough time and enough matter. They are proof that from millions to billions of suns worth of material can be crushed into a single dark point, and instead of just destroying things, they help build the very structure of the universe around them. So far, every black hole we've talked about formed either from a dying star or grew slowly inside a galaxy. But what if some black holes are even older than stars? Older than galaxies themselves? What if they were born in the very first moments after the Big Bang? This is the idea of primordial black holes that might have formed right at the dawn of time. Unlike stellar or supermassive black holes, these wouldn't come from a collapsing star. Instead, they might have formed when the universe was less than 1 second old. Back then, everything was extremely hot, extremely packed, and totally chaotic. Tiny bumps and dips in space might have squeezed matter so tightly that gravity crushed it into a black hole right there on the spot. If they really exist, primordial black holes could come in all kinds of sizes. Some might be as small as an atom, weighing only a few grams. Others could be as heavy as a mountain or even an asteroid. Imagine something smaller than a grain of sand, but heavier than Mount Everest. That's the strange scale we're talking about here. So why are scientists so interested in something they haven't even proven exists? The answer connects to one of the biggest mysteries in the universe, dark matter. For years, scientists have noticed that galaxies spin in ways that can't be explained just by the matter we can see. There must be some hidden mass holding everything together, but nobody knows exactly what it is. One idea is that dark matter isn't made of strange new particles at all, maybe it's made of countless tiny primordial black holes scattered everywhere across the universe. If that's true, it would mean the missing mass of the universe is actually made up of invisible black holes silently drifting through space. Some scientists even think trillions of them could be zooming through our solar system right now, even through Earth itself, without leaving any trace, because they'd be so small and their pull so tiny that we'd never even notice. There's even more to the mystery. If primordial black holes really did form in the early universe, they might explain how supermassive black holes grew so fast. Scientists have found giant black holes that already existed less than 1 billion years after the Big Bang, way too fast for normal stellar black holes to have grown that big on their own. But if primordial black holes acted like tiny seeds, giving supermassive black holes a head start, that mystery might finally make sense. So far, though, no one has ever directly seen a primordial black hole. Scientists search for tiny clues, like small flickers in starlight when an invisible object passes in front of a distant star, or little bursts of radiation that might happen if a tiny black hole slowly disappears through something called Hawking radiation. Every new telescope gives scientists another chance to catch one. But for now, they remain ghosts of theory, ideas, not proof. Still, the possibility is amazing. If scientists could prove primordial black holes are real, it wouldn't just solve the mystery of dark matter, it would connect the tiniest scales of quantum physics with the biggest scales of the whole universe. They would be leftover fossils from the very first moment of creation, carrying secrets from the beginning of everything. If this idea turns out to be true, then black holes aren't just what happens when things die, they might also be some of the very first things the universe ever built. When most people picture a black hole, they imagine something huge as heavy as a star, or even a whole galaxy. But what if black holes could also exist at the tiniest size imaginable, smaller than an atom? This is the strange and mostly theoretical idea of quantum black holes. Unlike black holes formed from stars or found at the center of galaxies, quantum black holes live in a totally different world, the place where two of science's biggest ideas crash into each other. One idea is Einstein's theory of gravity, which explains how huge things like stars and galaxies behave. The other is quantum mechanics, which explains the strange, unpredictable behavior of the tiniest particles. Normally, these two ideas stay in their own lanes and don't overlap. But if matter gets squeezed down to an impossibly tiny size, both sets of rules would apply at once, and right now, neither idea fully explains what would happen. This is where the idea of Planck-scale black holes comes in. The Planck length, an unbelievably tiny measurement, about 10 followed by 35 zeros smaller than a meter, is thought to be the smallest meaningful size in the universe. According to physics, a black hole at that size would be almost impossible to picture, way smaller than a single proton, yet still packed with incredible density. If something like this could exist, it would be the ultimate meeting point between gravity and quantum physics. But there's a catch: tiny black holes don't last long at all. Thanks to a famous idea from scientist Stephen Hawking, we now believe black holes slowly leak away their energy over time through something called Hawking radiation. For giant black holes, this process would take far longer than the entire age of the universe. But a black hole as small as a single particle would disappear almost instantly, releasing a tiny burst of energy and vanishing in a flash. Could these mini black holes actually exist? Some scientists think they might have formed during the wild, high-energy conditions of the very early universe. Others wonder if powerful particle collisions, like the ones created inside the Large Hadron Collider, could briefly create one for just a split second. So far, no proof has ever been found. But even without proof, this idea is far from silly. Quantum black holes force scientists to face one of the deepest questions in all of science: how do we combine gravity and quantum mechanics into one single idea? If quantum black holes could ever be shown to exist, even for a tiny fraction of a second, it could be a huge clue toward building what scientists call a theory of everything, one single idea that explains both the biggest and smallest things in the universe. Quantum black holes may never be seen directly. But their importance isn't about swallowing stars or shaping galaxies. It's about standing right at the edge of human knowledge, the place where our current science runs out of answers, and new discoveries are waiting to be made. We've now climbed through all 5 main levels of black holes, from dead stars to quantum mysteries. But the story doesn't end there. Scientists have come up with a few more fascinating ideas, some proven, some still pure imagination. Think of this as the bonus round, where science and fantasy meet. One of the coolest discoveries of recent years is the binary black hole, 2 black holes locked together, circling each other like cosmic dance partners. For billions of years, they spin closer and closer together until finally, they crash and merge in an enormous burst of energy. When this happens, it sends ripples through space and time itself. These ripples are called gravitational waves, and they were first detected in 2015 by the LIGO Observatory. That moment proved Einstein was right all along, and it also proved that pairs of colliding black holes really do exist out there in distant galaxies. Every new detection adds another chapter to this hidden cosmic story. Then there's an even stranger idea: white holes. If black holes are places where nothing can escape, white holes would be the exact opposite, places where nothing can go in, and only matter and energy can come out. Nobody has ever actually seen one, and most scientists doubt they're real. But the idea is still exciting to think about. Some scientists have even imagined that a white hole could be the other end of a black hole, connected by a tunnel through space called a wormhole. This is still just an idea for now, but it's a fun one to imagine. These bonus examples remind us that black holes aren't just objects out in space, they're also powerful thought experiments that test the limits of what we know and what we can observe. From black hole pairs that shake the entire universe when they collide, to strange mirror image objects that might not even exist, black holes keep challenging scientists to imagine bigger and dream further. From the collapse of giant stars all the way to the mysteries of the quantum world, black holes show us a universe far stranger and more amazing than we ever imagined. We've seen how black holes can be as tiny as an atom or as massive as billions of suns, shaping galaxies, bending time, and even testing the limits of science itself. Together, we climbed through all 5 levels: stellar, intermediate, supermassive, primordial, and quantum. Each one revealed a new layer of mystery. And beyond them, we even peeked into the strange, speculative worlds of binary black holes and white holes, where science meets imagination. What's most amazing is how each level builds on the last. Black holes aren't just objects of destruction, they might also be cosmic doorways to understanding how everything began. They remind us that the universe is both humbling and endlessly surprising. So now it's your turn to wonder, which type of black hole surprised you the most?